This is Flue, an open source framework for building AI agents made by the team behind Astro, which basically takes what Claude Code does as a harness and makes it 100% programmable. So things like skills, tools, sandboxes are supported out of the box. So you can create a fully featured agent harness and deploy it anywhere in just a few lines of TypeScript. But why would the Astro team decide to build an agent harness framework in the first place? And what's this cool trick you can do with sandboxes that allows you to run agents much cheaper? Hit subscribe and let's find out. Flue was built by the co-founder of Astro, and funnily enough, they didn't set out to build an agent harness framework. Fred and the team built Flue to run AI workflows inside of Astro's own GitHub repo. But when another engineer from Amplitude got their hands on it, the team realized that this is a tool that any agent should have access to, which actually makes sense if you think about it. I mean, let's take a look at Claude Code, for example. Underneath the terminal or UI chat interface is a harness. So it supports custom tools from MCP servers, it reads Claude MD files, it has sandbox support and support for reusable skills. This and much more enables the model to do real work, which Flue can give you in just a few lines of code. It does this by being built on top of Pi, which is a minimal agent harness itself, the same thing that OpenClaw is built on top of, and it wraps a real framework around Pi's agent core. Flue actually does something clever with sandboxes to help you run them a lot cheaper, which I'll talk about a bit later. But if you go back to the Claude Code example, it assumes that there's a human behind the wheel driving the agent, which is usually the case, but Flue doesn't have that same limitation. With Flue, you can build agents like Claude Code that require human input, but you can also build workflows that don't require a human at all, which is useful for agentic processes that are very specific and don't need to change that much. Now, you may be thinking, this sounds very similar to something like Astro or the Vercel AI SDK, and I'll talk about the differences a bit later on. In fact, the differences will be much more clear if we go through a simple demo. So let's go ahead and do that. So to get started, you'll have to install the Flue runtime, which is what your agent imports and runs on, and then you'll have to install the Flue CLI, which compiles and serves your agent. You'll also have to set up an API key from one of the many providers Pi supports. For this demo though, I'm going to use Anthropic, and then you'll have to run Flue init with a target, which creates a Flue config file so the CLI knows how to package your project. You can choose between Node or Cloudflare, and I'll talk about the differences in just a second. But I've already done these steps, and so let's have a look at what these files look like. So here are the typical files you get from a blank bun project, and some of these files aren't even used. If we have a look at index.ts, this isn't going to be used for anything. Neither is the README file. But what's actually going to be used is this Flue config ts file, which uses Vite behind the scenes, but tells the CI to use Node instead of Cloudflare. And the difference is Node uses a HTTP server on top of Hono, and Cloudflare will deploy your project to a worker with a durable object for persistence. Now, after you've done those steps, you'd have to create a new directory, either an agents one or a workflows one. We'll go through workflows a bit later, but for now I started with a simple agent, which contains the code in the documentation. And this basically sets a model and adds some instructions which appends to the system prompt. And that's it. That's all you need to create a basic Flue agent. Let's see it in action. To run it, we can use Flue connect, which builds and runs the agent, and we're matching the name of our TS file, which is hello world, before giving it an instance ID, which could be anything, so it could even be local 123. But this is useful if you have lots of agents running, and each agent can have its own unique ID. This is also useful for deploying to Cloudflare, because this ID maps onto its own durable object instance. So now if we hit enter, we can see it loads the config, reads the target, and runs the agent it's found. Now we don't have an agent MD file, but if we did, it would use that. And now it's built the agents to this server.mjs file, and it's given us the ability to enter a prompt. So I can say something like, give me a random joke. And here we can see the agent starts thinking, it responds, so streaming its lifecycle. Then it gives me a joke, asks me for another one, but then below here, it prints the final JSON, which comprises of the text, as well as some input and output tokens, the cost of the whole prompt, and the model that was used. Of course, we could continue talking to this agent, but for now, I'm going to shut it down. And that is an example of building a basic agent with Flue. Let's do something a bit more complicated. Let's build a workflow to help generate some titles for this YouTube video. And to do that, again, we're creating an agent with some more complex instructions. And this time we actually have a skill. So the skill is imported here with a skill import attribute. And here, notice we're no longer exporting the agent itself, but this time we're exporting a function called run. And what this does is it initializes the agent for the workflow and then opens a session in the harness. Now what happens next is quite interesting. So here what's going on is we are getting the path from the payload, which was set here in this flux context type. So if we change the name here to file, we would get a type error. And here it's getting the file, which I've called script, and passing that in as a prompt. So this all makes sense if we have a look at the instructions over here, which we're telling it to study the script and give me 10 clickbait YouTube titles using the title score skill to rank them. So let's see if this works. But before we do, I want to make it obvious that workflows are in the workflows directory and skills are in the skills directory from the project's root. And to run this workflow, we need to run Flue run with the name of our workflow. In my case, it's YT titles, followed by the target and the JSON payload, which is the path for this script. So if we hit enter, we'll see we get a workflow ID. And here it's doing something a bit odd. It's actually looking around for the skill, even though I've specified it earlier. And now in this reasoning, it's telling me there aren't any files on the file system. Why is it doing that? So by default, Flue runs agents in a sandbox using just bash. All it has access to is the skills description, which has been registered over here, but it doesn't have access to any of these files related to the skill. And the skill itself, if we have a look at it, it actually runs a Python script using bash in order to come up with an accurate vidIQ style score for a YouTube title. So to fix that, I'm going to import local from Flue runtime node, which tells Flue to run the agent on my local system so it has access to all my files and can run Python scripts. If you're security conscious, I'll explain how you can get around this later on in the video. But we're also going to change the current working directory to the skill inside the skills directory of this project so that Flue doesn't have to look around to find the exact files it needs. And now when I run this workflow, we can see Flue immediately reads the skill MD file and is able to generate the 10 clickbait titles with a score for each of them. Now, if you don't want to give your agent or workflow access to your local system, what you could do instead is to create a custom tool from the Python file. So here I'm loading the Python file in the skill and creating a tool called score title, which uses ValueBot to verify the parameters and then runs the Python script. Then we can register this tool inside our agent and everything should work as expected. But now let's go back to the previous project and say we want to trigger it based on a HTTP post call. Well, there's just one thing we need to do to enable that, and that is simply to add the root middleware. Now all we have to do is build the Flue project, specify our target, an optional port, and then run our server file. And now it's listening on the port we specified. Note that the server.js file inlines any agents or workflows we have. So we just need this file if we wanted to deploy it anywhere that supports Node.js. Now I can run curl with the post method to the port that was specified, select a workflow, and give it some data, which gives us a workflow ID. And then if we curl for workflows, specifying our specific workflow ID, I'm piping to JQ just to make it easier to read, we can see information about our workflow and a summary of the results. Of course, Flue supports WebSockets instead of HTTP if you wanted to stream the workflow information. Now, as usual, there are so many features Flue has that I didn't get around to going through, like agent profiles for reusable agents, support for Daytona, Cloudflare sandboxes, or any other sandbox just by using a URL, adding custom routes for auth or health checks, and even support for sub-agents. But how does this compare to another open source AI agent framework like Mastra? Well, the last time I used Mastra was when I made this video, which you can pause this video and go and watch if you want a refresher on what it is. But when I did use it, you still had to manually set up the sessions, the memory, the sandbox, and tool loading yourself. It was much more of a granular step-by-step process, and I'm not sure if that has changed to become more simple, but I think the approach that Flue is taking is completely different. It's more of a harness-first approach and assumes that you're going to be using these features from the get-go. Speaking of sandboxes, Flue actually does something really clever with them. So each agent gets its own sandbox by default, which I explained earlier in the demo, but this sandbox is powered by Vercel's just bash, which re-implements bash in TypeScript. So it runs this sandbox in memory instead of a real container, meaning you get access to grep, glob, and read tools without paying for a container every time, which has to boot up a whole Linux machine just before you can do anything. Meaning Flue runs thousands of agents for next to nothing, and you can opt into a real container only when you need one.